So up until now, our graphing, when we've been graphing on a coordinate plane with a y-axis and an x-axis, up until now, we've only dealt with equations, equal signs, right? Y equals mx plus b. Y equals 1/2 x plus 10. Y equals, right? Well, now we're going to start talking about how to graph them when they're on a coordinate plane. We have an x and a y, but it's not going to be equals. It's going to be an unequal sign, basically a greater than or a less than sign, right? So remember those signs? Let me just make sure I'm on the, okay. Remember this? That means greater than, right? Greater than. This means greater than or equal to. Greater than or equal to, right? This is less than, and this is less than or equal to. Less than or equal to, right? So those are what we're going to look at when we're working with trying to graph an equation that is written in slope-intercept form. Like y, instead of y equals mx plus b, it's going to be y is greater than mx plus b, or y is less than mx plus b. And that is going to change our graph a little bit. It's not going to change the line itself, but you're going to see how that affects things. But even before we go into graphing, I'm going to just say, because on the homework, you're going to get something that says this. It'll say, an example would say, tell if ordered pair is a solution to the inequality. So I'd say if this were the ordered pair, 2, 4, and the inequality was y is greater than 4x minus 2. Okay? So there's my inequality. Y is greater than 4x minus 2. And here's my ordered pair. And I'm asked to tell whether this is a solution of this. So the way I do it is I just substitute these in. Did I give you an x and a y here?
Yes.
Yeah, this is an x and that's a y. It's always in alphabetical order. So x, y. So I rewrite this. Where it says y, instead of writing y, what am I going to write? 4, right? You guys see what I'm doing?
Yeah.
Y is 4. You guys all see that? Y is 4. So I'm writing, instead of y, I'm writing 4. Then I'm putting the greater than sign. I'm just doing it right underneath this inequality. And then it says 4. I put the 4 underneath that. And instead of x, I'm going to come over here and I'm going to put a 2 there. But it's times 2, right? 4 times 2, because that's 4 times x. And then I'm going to put minus 2. So 4, now I'm going to simplify. 4 is greater than, 4 times 2 is 8, minus 2. So 4 is greater than 6. Is that true or false?
False.
That is false, right? Therefore, no, this is not a solution to the ordered pair. If this were true, if it said 4 is greater than 0, that would be true, right?
4 is greater than 0.
And then I would say, yes, it is an ordered pair. It is a solution. That ordered pair is a solution. Does that make sense?
Yeah.
Right? You're just substituting those in to see if you get a true answer. If it's true, then yes, it's a solution. If it's false, no, it is not a solution. Make sense? Yes, Graham.
Will there ever be y's on both sides of the inequality?
Well, there could be, but I'm not for what I'm doing right now. I mean, but it could happen, but you could easily get, you just subtract the y's, so you get the y's on the same side. It's a good question.
It's kind of like the same as the equal
Right.
sign.
Yeah, and yeah, exactly. It's the same as an equal sign. Now, now I'm going to talk about graphing these, right? So if you're asked to graph these, so let's say here's my graph. This is my y-axis, this is my x-axis, and I have this formula, this equation. Y is less than, I don't know, 1/2 x minus 3. Okay? All right. I'm going to start to graph this just like I would graph it if it said y equals 1/2 x minus 3. But I'm not going to draw the line yet. Okay? I'm just going to plot my points. I know that I immediately go down to this, right? That's my y-intercept. So I go down 3. 1, 2, 3, and I put a dot. And then I know my slope is rise over run. I rise 1 and I run 2. So I'm going to rise 1 and I'm going to run 2. I rise 1, run 2, and I put a dot. Now would you agree with me I'm ready to draw a line?
Yeah.
All right. Now this is one of the things that's different. If it says greater than or equal to, or less than or equal to, you see that little line under there? That means it also equals the line. Therefore, I would draw a solid line. So that little line there says draw a solid line. But there's no little line there. So it doesn't equal, the y does not equal this. So I can't draw a solid line. So I have to actually draw a dashed line. Does that make sense? Because it doesn't actually equal that line, but that line is actually called a boundary line. It is the boundary of the answer, right? The answer goes to that line, but it doesn't equal that line. It doesn't include that line. Does that make sense? All right. Now, the other thing, though, is that there's going to be an infinite number of answers to this. I haven't finished yet. I have to shade, because it's either going to be all of this area below this line, or it's going to be all of this area above that boundary line. It's one or the other. It's always one or the other. If something is true above it, then it's always above. Everything is true above it. If something is true below it, it's always below. So let's choose an easy point. What is the easiest point on the graph?
1, 1.
What's even easier? Yes, 0, 0. Don't you agree with me that 0, 0 would be really easy to substitute into an equation?
Yeah.
Because 0 would knock everything out, right? It would just, we wouldn't have to do any computations. So I'm going to just test this little spot right here. So that is 0, 0, right? 0, 0. That would means my y would be 0 and my x would be 0. I'm going to see if it gives me a true statement, okay? So I'm going to say 0 is less than, now wouldn't 1/2 times 0 just be 0? So I don't even have to write it. Well, I could, but I don't have to, because that just crosses out. So it's just 0 is less than -3. Is that true?
No.
Is 0 less than -3?
No.
No, that's false. That is false. All right, what does that tell me? That tells me that this side of this boundary line is not a solution. And it also tells me another thing. It tells me that the other side of the boundary line is a solution. That means every point down here is a solution. And so you shade it in. You just go like this. And that is how you do graph an inequality. Right? And you could keep going, whatever, right? But that's how you solve an inequality. How you graph one. It's always going to have a shaded area. Always. Okay?
So we would shade it.
So, yeah. So basically, I know that this point right here is a solution to this inequality. I know that this point right here is a solution to this inequality. Now, I'm going to ask a trick question. Is this point a solution to the inequality?
No.
No, because it's on a dotted line. It doesn't include the line. It starts at the line, but it doesn't include the line, right? Now, had I done this, though, had I had written it like this with a as less than or equal to, now that line would be solid.
But
Would you still shade it in?
and then you would still shade it in.
Okay.
It would be the same thing. Would that
Oh,
make
so
sense?
if that was true, then that line would be solid.
Well, if this were, if this said y is less than or equal to, then this would be solid,
Okay.
right? All right, let's try one more.
Can we do this one on the actual graph?
Yeah, you want to try it? Try it on your board. Try this on your board right now. All right, so try y is greater than
What is that?
2x minus 2. Y is greater than 2x minus 2.
What are we doing?
Graph this one. And as you do it, I'm going to do it as well. So you can see and compare. So what point did you use to choose which way to shade? So, is 0 greater than negative 2? Is 0 greater than negative 2?
Yes. Is that right?
So you would, that is right. That is right. 0 is great. If I tried 0, 0 right here, right? 0 is greater than negative 2. Because 0,
Gary.
right? So, but look, yes, but watch. You guys, half of you are right and half of you are wrong. If I choose 0, 0, 0
That's true, Gary?
is greater than negative 2. Because this crosses out. That's true. 0 is bigger than negative 2. Negative 2 is over here. Here's 0. Right? Therefore, this is a solution right here. You guys, shh. You see, this is a solution. So therefore, I shade here. You see? You've got to be really careful when you do this. That make so that you're sure which side to
So
shade.
that would be right.
Correct. That's right. Excellent. Okay? Makes sense? All right. That's it. We are done with the lecture, and I'll give the homework.